Given an integer n, write a Python function that returns true if the binary representation of x is in palindrome, else return false. So what is a palindrome? Palindrome means that it's the same reading from the start or reading from the end. So ABC, no, this was a bad example. ABA is a palindrome because if you read it like ABA and if you read it reversed ABA, it's the same thing. So that's a palindrome. And we want to get a binary representation of a number. So we could have just used the string to check if it's a palindrome, but in this case we're going to use a binary number, so nothing too special about that. So let us first give a number. Let's say our number is 9, and now we want to call binary palindrome, and we want to give the number here as an input. So let us define that function. It's going to take our number as an input, and we need to convert our number to binary. So this is pretty simple. We just call bin from our number, and now we get a binary representation. I could print that out in order for you to see what this is going to look like. And as you can see, it starts with 0b to represent it's a binary, but this is our binary number. So we need to consider this. We can't use this OB in our calculations. What we need now to do is cut that OB. So binary is going to be equal to binary. And as you remember slicing from lists, we can slice. So if you use this, this is just going to return a copy of our list. But what we can do is give it a range. So for example, let's say we give it a range of 1 to 2, or yeah, so this is going only to return us everything in the range starting from 1 all the way up to 2, not including 2. So if you do it like that, it's going to return everything starting from 1 till the end. And if you do it like maybe that, it's going to return everything from 5 till from 0 till 5, not including 5. So what we want to do is cut the first 2. So we're just going to set the 2 there. And now we want to check if they are equal. So if binary, which is now just going to be our binary without the OB. If this is equal to binary, now we just need to reverse it. And in order to reverse it, we call -1. So -1 would just return us the last element from our list. So if we have a list, let me explain that. If we have a list like 1, 2, 3, and 4, so this is position 0, 1, 2, and 3. And this is position -1, -2, -3, and -4. So something you need to take into consideration, since this is not -0, it wouldn't make too much sense. The last one is -1. So now we can count to the beginning. And one more thing we can do is we can give it a stepper. So a stepper is going to it's going to step throughout our list. So let's say we give it a stepper of -2, then it's going to start from -1, so 4, and it's going to take into consideration every second value. So let me add a few more values here. So in this case, it would look at 7, 5, 3, and 1. But we want to give it a stepper of -1. So it's going to look at every value, but starting from the last one and going up to the first one. So, and if this is true, then we are going to print it is a palindrome, and else we're going to print not a palindrome. Let me run this now, and it is a palindrome. Great. Let us, for example, use something like 10. Not a palindrome. I could also maybe print out how the binary looks like. So binary. So that you see that this really is true. So 1 0 1 0 is not the same forwards and backwards. But if you, for example, use a 9 here, we see 1 0 0 1. So it's the same from both ways. So yeah, this wraps up our fourth example.